To the data channel, and you're watching SQL Bootcamp for data professionals. As part of topic 11, we will be discussing about the SQL indexes. So you might definitely heard about SQL indexes, and you might already know that indexes are kind of a used to increase the performance when you're writing the queries. Yeah, that is true. But we will understand in detail how exactly the indexing work and what are the different types of indexes and what are the drawbacks of using indexes, right? And we'll also see different pros and cons of using them. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So indexes are a concept of SQL, right? So it is when we have a tables in SQL databases, definitely there will be tables, and each tables will be having the columns. And indexing is a optimization technique that applies on a particular columns or set of columns, right? And so by creating an index on a columns, so what you can enable is you can make the performance better when you are querying using those particular columns, right? And data can be retrieved faster. So indexing, like it's a concept of basically like you kind of make the query faster by creating the indexes, right? Indexes are like a pointers in the physical memory location. So these will work like a pointers where when you're querying on a particular when you want to search a particular value in a particular column, like a employee name, you want to search by employee name, which is an indexed column. So then for each employee name, so there will be the location, the physical location will be kind of a the pointer of that physical locations will be stored as a dictionary kind of a thing. So where like whenever there is a query, it immediately knows where which location exactly it has to go and pick the records instead of searching the long list of records, right? So that's the basic concept of indexing. So indexing is a data structure. Okay, that's clear, right? So indexing work in it is itself is a data structure. Often it's a B tree or a hash table. So that improves the speed of the data retrieval operations on a table at cost of additional space, storage space, and the slower write operations. Basically, there is a compromise that you are doing, right? So there's a slight compromise in the additional storage space. So nowadays we are having a lot of storage and we are using the cloud versions where you have the storage almost unlimited storage, what we can say. So that's the reason. So this is not at all a problem. And the slower operations, so slower write operations would also be not a problem because we have a good CPU. We can also scale the processing capability of a particular database, right? So that is why this also should not be a much of a problem, right? So that is why indexing is a preferred choice. Definitely, if you want to create a reporting layer where you want to have the reports retrieve the data faster. Okay. And let's take an example. You have an employee table which is having employee ID, first name, last name, department, salary. So you can choose any of these columns, okay, to kind of an index. You can choose employee ID, first name, last name, department, salary, anything. But usually primary key will not be chosen as an indexing. Usually I would say because the reason is most the primary keys, right? Most of the times the database, it depends on the database, but most of the database will treat it as a by default they will create an index for the primary key because it is a unique uniquely identifiable column, right? So that way automatically that column will be indexed in most of the cases in the current versions of the databases that we are using. Similarly, if you are using first name, last name, department and salary, so these you can choose any of these as an index. So let's suppose you choose last name as an index, right? So why you choose a last name as an index? So you can choose first name also, right? But the thing is, you should know which is the most frequently used column in your where clause. Suppose you are having a where clause. So in your where clause or the reporting layer, you have a reporting layer which is mostly using this particular column, last name. So that is where you choose last name as last name to index. Okay. So this is like let's suppose this particular query select star from employees where it is having 100 million records or 200 million records. So it is taking say for example 7 seconds. Okay. So next I will index the last name column from this table because I'm using this last name most frequently in my query or reporting. So I'll create index, and I'll give an index name on employee table. This is my table, and so this is my column. So when you run that, the automatically in the background, the indexes are created for that particular column and that employee in that employee table. So instead of like say here it was taking 7 seconds previously, right? So here it was taking 7 seconds, for example, to work on a to get the retrieve from the 100 million records. So here it will just take, say, for example, 2.5 seconds. So there will be drastic improvement. Okay, how does exactly this improvement happens? So if you are excited to know that, so definitely we will move to this next slide. So basically, what I'm explaining here need not be like it is not important to kind of understand from the developer perspective. The reason is so this is happening internally. When I say internally, whenever you run this particular query, right, create index, whenever you run this query, so internally database will decide. So it depends on the version of the database, and it depends on what kind of databases you are using, SQL and MySQL and PostgreSQL, Vertica, IBM DB2. So what kind of databases you are choosing, and each database have its own mechanism to choose which kind of indexing internally it has to happen. Okay, there is a B tree index. Okay, and there is a hash table index. There is a bitmap index. There is a GIST and GIN index. But most commonly, B tree and hash table are most commonly used. Okay, so it depends on the data. It depends on the database versions, databases, uh, and that particular which is the most optimal that will be decided by the database in the runtime itself whenever you create an index. So it will see the data what is suitable for it, right? So it will automatically, maybe based on the volume, kind of a query that you are using frequently, it can change from B tree to hash table internally. So but everything happens internally. Okay, B tree is it's a kind of a tree structure, right? You might have heard in data structure there's a binary tree concept. So where it kind of create a tree, balanced tree. So where it will use it for a retrieval of a data. It is a data structure again. Similarly, hashing is also one of the technique where hash indexes its query faster. Let's take an example here, right? Visually, like whenever a user pass a query on a like select star for my employee where last name equal to so and so, what happens is so it actually goes to the index first. Before going to the table, it will go to the index first, and in the index, it will see the memory location. Okay, for say for example, last name XYZ, uh, this is the memory index, right? So immediately using that memory index, it exactly knows where exactly this data is stored using this pointer. Okay, it's like a pointer. Okay, so instead of traversing through the entire table of say 100 million records, it actually points out to the one or only few records where the memory location is pointing it. So you can imagine, right? Instead of taking 7 seconds to kind of a traverse entire 100 million records, it was able to fetch in just 1 or 2 seconds. Okay, so that is how the indexing internally works. Okay, and so in this case also, right, like suppose you have a index where your last name is your index, right? Like they say for example there are four Smith as a last name, so it knows all the locations of all the four Smiths. So these are the memory location. This is 137. This is the memory location actually in that particular partition you can think of. Okay, so it will know the memory location, and it exactly goes to that memory locations, and it can retrieve the data for you wherever the last name is Smith. So all the records will be fetched out. Okay, so that's how indexing internally works, and when to use what. So there is a primary key index. You can use there are different types of index basically, and you need to understand which particular index you need to use at what time. Okay, so primary index is a simple, right? So basically you're just create index, and you're creating an index here. But the next is unique index. So where the syntax, if you see, you're just adding a unique here, rest everything is similar. So you're creating index on employees email, employees table email ID. So this particular unique, when you're creating a unique index, it also makes sure that the indexed column contains only unique values. Okay. So then there is a something called as composite, sorry, clustered index. So clustered index is uh, basically it physically arranges the data in the table based on the index. A table can have only one cluster index because the table's row are stored in this particular in the particular order. In many databases, the primary key creates a cluster index by default, as I was telling, right? So when your primary key is automatically created as a clustered index. Okay. So non-clustered index next is, so which basically mean that this type of index does not affect the physical order of the data. It contains a pointer to the actual data row itself, making it possible to have multiple non-clustered indexes. And the syntax is something like this. So it's important to understand here, right? Cluster index and non-cluster index, the difference, right? In cluster indexes, as I was saying, it physically arranges the data in the table based on the indexes. Okay, that means in the memory, when it is arranging at a pointer level, it physically arranges in such a way that, okay, um, the data in the table based on the particular index. So it will sort that in the memory itself. Okay, it clusters that in the memory itself. However, in the non-clustered cases, so it will not impact the physical order. So it will keep the physical order however it is stored. So it will not disturb that. Um, it contains a pointer to the actual data. It just create a pointers to that particular. So if you really see, it doesn't make from the developer perspective that much kind of a implication when to use clustered, when to not use non-clustered, unless there is a very peculiar case where you want to choose between them. But most common is a primary index and unique index. Okay. So next, last we will see composite index. Composite index is nothing but you can create an index based on the combination of two or more columns. So you think last name and department, this combination is mostly used, right? In many of the cases, in the filters that you are applying. So then you can use a composite index as well. So there should be a best practices when you're using clusters, right? So let's take one by one. So index selective columns. What that means is, so index columns that are frequently used in where clause or join conditions, columns with a high degree of uniqueness. That means, suppose there is a column 1, column 2, column 3, column 4, column 5. So you can literally create index on all of the 5 columns, or you can selectively smartly use 1 or 2 columns for the indexes. So you should always choose the second option, because the more indexes you create, the more memory it is utilizing, the more performance also can degrade, because there are a lot of indexes, and then you choose to have waste a lot of memory spill or in the background. Okay. So you should definitely, if there are 10 to 15 columns in a table, definitely in the reporting, only maybe 20-30% of the columns will be used where you apply where condition and join conditions. So choose those particular columns very smartly. Okay. And then only those columns should be kind of a indexed, not all the columns. And avoid indexing frequently updated columns. Let's suppose example, um, there is a column in the employee table where which is most frequently updated. So say for example, there is a department ID for that matter, right? So it might be getting frequently updated. So that should not be your column. And let's take example one more is like in the customer table. So last update column is there. Last update timestamp, right? So last update timestamp is usually it keeps on updating, right? Because when as and when the customer logs in or do some transaction, so there's a last update timestamp, that particular column will be keep on very frequently updated, right? So those column you have to strictly avoid, because if you choose those particular columns, so then it might lead to a because there is a lot of inserts, deletes are happening, it can slow down those operations. So then composite indexing and order. Basically, when you're using composite index, the order of the columns also matters, right? The indexes will mostly efficient for the queries that use the leftmost columns in the index. For example, the composite key on the, so you choose a composite key where you have a last name, comma, first name. So this is your combination, right? Last name, comma, first name. So this will work for a query using last name or both last name and first name, but not for the query using first name, because the left hand side what you are using is a priority. So you should, in the filter, you should either use last name and first name both, or you just use the last name. So if you use first name, that will not be of much useful. So composite indexing, when you are doing, the order also does matter. Okay, choose that order carefully. Using indexes for sorting and searching, right? So in this case, indexes can optimize queries that uses order by or group by operations. So that was also important. So wherever you are performing order by and group by, so those column also can be chosen as a indexes. And then you have limit the number of indexes. What that means is, while indexes speed up the reads, they slow down the operations also. That's why you need to kind of a balance the use of indexes, ensuring your optimization is critical queries without over indexing also. For example, index frequently searched fields, but don't create unnecessary index on every column, that as we discussed. And then we have a partial index. Partial index is very specific to the PostgreSQL SQL kind of database, where the index only a subset of rows based on the condition, which can reduce the storage cost and improve the query performance. So that again depends on, this is not much of a used, so that's why I don't want to go in detail on that. So next we have covering index. Covering index concept is, this is a type of non-clustered index that contains all the columns of the query needs, which eliminates the need of additional lookups to retrieve. This can speed up the queries further. Okay, that means this is, as we said, this is a non-clustered index. So clustered and non-clustered we have already discussed. So here in this non-clustered, we are covering basically, this contains literally all the columns a query needs, which eliminates the need of additional lookup for the data retrieval. This can speed up the query in the long run. So this is also not much used in the real time. And we have last is indexing for joins. So when performing joins between two tables, also it is useful, and it's also beneficial to have indexes on the columns that you're using in join condition. Suppose you want to join the employee table and department table with the department ID in both employee table and department table. So you can index the department table in the both the tables, which will definitely increase the join performance as well. So then we have a trade-offs of indexing, right? So this is important to understand. What is the pros and what is the cons of using indexing? So definitely indexing is a concept where it is used for the performance optimization, or optimizing, getting the optimal performance benefit, right? So to speed up the query or reporting performance, right? So speed up the select queries, especially select queries we are talking about here, because most of the time we do operation using select for the reporting, and those queries, especially when working with the large data sets. So this is important. Indexing doesn't matter. You not create an index on the small tables, right? So the indexing is matters where you have a large tables where you have a 10 million or 20 million or hundreds of millions of records. So then only the indexing should matter. Otherwise, you should not create unnecessary indexes on the tables. So, and also it enables faster lookups, efficient sorting. Sorting also will help, and joins also it will help. Basically, selecting, sorting, joining any reporting layer, any analysis you want to perform, data analysis. So wherever you are using a filter conditions, right? So that there it will come into picture. And also it improves the query performance for commonly filtered and sorted columns. but also it has a negatives. Okay, what are the negatives? Indexes required additional space and storage because it has to internally, it has to, as we see saw, right, like it creates it is a data structure. The additional data structure is created between when you're querying, so it has to go to that data structure, so which is created newly when you create an index. So uh, definitely it will add up the space, and it also like slow down the writes. Okay, when you're inserting update and delete operation are slower because the database must also have the also update the indexes. Okay, so that is why it's important to understand not to choose columns which are frequently updated or inserted. So otherwise the indexes keep on kind of so you should never create an index on transaction tables. Okay, so because like if it is very frequently updating, right, every second there is a transactions happening, so that can slow down that operation because every time there is a write happening, the indexes are getting updated internally. Okay, so also there is a maintenance overhead. Indexes must be maintained, especially when dealing with the frequently data changes. So it can create a database issues, optimize. It can create a database locks for that matter, because if there are, you choose a column where there is a lot of updates are happening and inserts are happening, and that can really be a overhead for the database to maintain it. Okay. So this is particularly concept of indexing. So this is more of a theoretical video. So understanding this indexes in theoretical is very important. Practically, it's just about the syntax where you create index on the table. But practically understanding is crucial. Hope you are able to understand the indexing concept in detail, and this will hope it will be useful for you. So indexes are powerful tools for improving query performance, but they must be used judiciously. So over indexing and can also be degrading the performance for write heavy applications, while under indexing on the other side can slow down the read heavy operations. So it is a trade-off that you need to understand here between read and write, and smartly kind of use the columns you need to choose, and which when you want to index and all those things. It's a smart decision you have to make as a developer or a administrator. So the key is to analyze the query patterns and index the columns that are frequently accessed, sorted, or used in join operations. So hope this was useful. Thanks for watching.